So let's see what we can do now. We'll start with this, what is called, suppose I give you a galvanic cell. A galvanic cell is formed by using a standard zinc and copper, using standard zinc and copper electrodes. Clear? Whose reduction potentials we calculated last day only, isn't it? Whose reduction potentials are, what are the reduction potentials? For zinc, it is minus 0.76 volt, and for copper, it is 0.34 volts. Respectively, means in the same order, isn't it? Now, what we have to do, we have to find out something from here. These two we already know. Clear? So if I ask you, write, no, let's take it like this way. Which of these forms the anode and cathode? Out of these two, which of them will form anode and which of them will form cathode? That means copper and zinc. Whether copper will form the anode or zinc will form the anode, that we have to mention. Here, then I can say, write the cell representation. Then write the cell reaction. And then finally, one more thing, find the standard cell potential. Find the standard cell potential. Understood? So I have given you which of them forms the anode and cathode, that you have to explain, how to write the cell representation, how to write the cell reaction, and how to you have to find out the standard cell potential. So how do we do these things? Clear? So to do this, what we do, we take the help of the potentials which are given. So you already know the reduction potentials are given. E, they are standard. So zinc ion to zinc. This is your reduction potential. This reduction potential is equals to minus 0.76 volt. This is given. And then E naught copper to copper, copper ion to copper is given 0.34 volt. So these two are given. Now from this, we have to state which of them will form the anode and which of them will form the cathode. So to write down which will form cathode and anode, what we'll do, we'll compare these two. Which of these electrode potentials are higher? If you compare these two, which will have higher? Which has higher? This is higher, isn't it? This has higher reduction potential, isn't it? So since it is higher reduction potential, therefore is easily reduced That means copper will be reduced. So what will happen? Zinc will be oxidized, isn't it? So if this is reduced, what will it form? Therefore, forms the cathode. Whatever is reduced will always form the cathode, and whatever is oxidized will form the anode. So what you'll do, whichever two potentials are given. Yes, any problem, Sudeep?
Sir,
Yes.
sir, minus sign is show the reduction.
Minus, these are reduction potentials, isn't it? So which is higher? This has a lower value. Minus means it will be less, and this is plus, so it is more, isn't it? So what will happen? The
Yes.
higher value can easily be reduced. Whichever has higher
Yes, sir.
reduction potential, just compare the value. These both are reduction. Understood? Both are reduction.
Yes, sir.
So whichever has higher value, the higher value will always be reduced and the lower value will be oxidized. Understood? Okay. So what we have, higher reduction potential was there, so it is easily reduced and therefore it forms the cathode. That means the other one will form the anode, isn't it? So what will be your answer
Thank
of
you,
the
sir.
first? Yes. What will be the answer of your first one? Zinc
Sir,
is
zinc is anode.
oxidized. Therefore, is the anode. Copper is reduced. Therefore, is the cathode. Copper is reduced. Therefore, is the. Understood? So whichever is oxidized and whichever is reduced, you can find out with the help of values which are given. You just compare the values, whichever has a higher value, like here we said the values was 0.76 and 0.34. So this is higher, so it will be reduced, so it is cathode. So zinc will be oxidized, so it is anode. Copper is reduced, so it is cathode. Understood? So whenever two metals are given, you can easily find out which is oxidized and which is reduced. Isn't it? Then the next thing, the second one, what you have to write down? Cell representation. So to write the cell representation, you know, whenever we write the cell representation, then in that case, what happens? First we write the anode, then salt bridge, and then cathode. Salt bridge details you don't have to write. Anode. What is the anode here? You have already written anode is zinc, and zinc is oxidized. So since it is oxidized, what will I write down? Zn will become Zn2 plus. Zinc is oxidized, so Zn slash Zn2 plus, and this will have a concentration since they are standard 1 molar. Then double slash means salt bridge is the cathode. What is a cathode? Copper, and copper is reduced. So you'll write this in reduced form, Cu2 plus, concentration is 1 molar slash Cu. Cu is a solid only, so no problem here, isn't it? So this is how you write it down. Understood? So this is your cell representation. Always first anode is written and then cathode. Many times in your book or in many places you'll see left and right written. E of left, E of right, those things are written. Then in that case, anode is your left and this is your right. This is your left. L is written, means left, and this is your right. Understood? Representations, there are many representations. So you just have to follow one of them, the one which you can understand, you follow that. Then the next thing what you have to do, number 3 is cell reaction. You have to write down the cell reaction. How will you write down the cell reaction? To write the cell reaction, you have the anode reaction. You can see your anode. This is the change taking place in anode. So what has happened? Zinc has become Zn2 plus. That means zinc has lost 2 electron and formed this. Same way, cathode reaction. In cathode, what has happened? Copper ion has become copper. So Cu2 plus has become Cu. So in this case, it has gained 2 electron and formed this. So cathode and anode, the reactions you already know. Since you know the reactions of cathode and anode, you just have to add them up. But before adding them, always remember what should be there? The number of electrons gained and the number of electrons lost has to be equal. So here, in both the cases, it is exactly same. 2 electron and 2 electron. So you don't have to do anything. Suppose it was not the same. In many cases, it may not be same. So if it is not same, what you have to do? You have to make it same just by multiplying the equations. You have done simultaneous equations previously in mathematics. So same method will multiply and make it equal. So these two things, now if I add it, you'll get the cell reaction. What will happen? Electrons will always cancel. Remember that. In your cell reaction, you won't get any electrons. So what will be left? Zinc combines with this. It will form Zn2 plus and Cu. Understood? So cell reaction, you can easily get it. Write the anode reaction, cathode reaction, make the number of electrons equal, and then add them up. That is the only thing which you have to do. Then finally, what was asked? If I write down number 4, what was it? The cell potential. So how to get the cell potential? You know your formula, what is it? E cell. E cell is standard, so we write this is equals to E reduction. Remember, E naught reduction of cathode minus E naught reduction of anode. So both are reduction. We can write plus here, then this will be oxidation. So you'll get confused there. So always try to use reduction. Now, What is the anode and what is the cathode? You already know, isn't it? So I'll just write down like this for you to understand better. E naught cathode. Cathode was copper, and it is reduced. Reduction means Cu 2 plus slash Cu. And same way, zinc was a anode, so Zn2 plus slash Zn. These two values are given in a question itself. What is the value given? You already know it. How much is given? For cathode, it was how much? 0.34. And this was minus 0.76 volt. Isn't it? So this will become 0.34 minus into minus becomes plus 0.76 volt. Now you can simply add it up. What will you get? 1.10, I think, isn't it? So the cell potential is how much? 1.10 volt, isn't it? E cell, E naught cell is equals to 1.10. This E naught cell is also called EMF of the cell. It's also called EMF of the cell. So this way you can write down all these things. Understood? Copied, all of you? Hurry up. Let me know when your thing is over. Done. Then we'll continue with a similar question here. Let's see whether you can do it or not. Yeah. So I'll give you a new question now. A galvanic cell is formed by using a galvanic cell is formed by using suppose I give you magnesium and silver electrodes whose standard reduction potentials remember these values will be given, but these values, to find it out, what you have, there is a series. Clear? That series is called electrochemical series. So from that electrochemical series, usually we find the value of these things. It's not that you have to learn the electrochemical series, but we use the electrochemical series and find out the potentials of this. Yeah, so we'll see that also later on, but I'll just give you the values here. If I take this potentials of magnesium, magnesium is minus 2.36 volt and silver is 0.80 volt respectively. Yeah, the reduction potentials are given, isn't it? Now, what can be asked? From here, I can ask you, state. Number 1, state which of them forms the anode and cathode. Which of them is forming the anode and which of them is forming the cathode. Number 2, write the cell representation and number 3, write the cell reaction and number 4, calculate the standard cell potential. Clear? Everything is given. I've given you a similar question before this only, so you can easily try it. You can just add one more word so that there's no confusion. Standard galvanic cell is formed. A standard galvanic cell is formed by using magnesium and silver electrode. That means magnesium and silver both are standard. Okay, in standard conditions, their potentials are given. Clear? So you have to say which of them forms the anode, which forms the cathode. So hurry up, quickly do it and show it to me. Have you done the first one? Done the first one? Which of them is a cathode and which of them is an anode? For that, I've told you, you'll take the value of E naught of the two things. One is magnesium, since it is reduction, Mg2 plus / Mg. How much is it? Is given minus 2.36, and E naught Ag plus Ag. That is given how much? 0.80. So these are your potentials which are given. Now what will you do? From this only you can state which is cathode and which is anode. How will you find out? You compare these two, which is higher? Sudeep, which is higher?
Sir, I think magnesium.
Which is higher?
Magnesium.
It is silver. You can see there. Sinjoy has written correctly only. It is silver. Isn't it? Silver is positive and this is negative. Positive one is always higher. So this has higher reduction potential. Isn't it? Higher reduction potential. So what will happen? Therefore, is easily reduced. Whichever has higher reduction potential will easily be reduced. So is easily reduced means therefore forms the cathode. If the oxidation potential is given, then the higher one will be oxidized, isn't it? But here what is given? Reduction potential. So whichever is higher is reduced. So you know which one is your cathode. Then What will you do? Once you got this, you can easily write down the answer for your first one. What will happen? Magnesium is oxidized, therefore forms the anode, isn't it? And silver is reduced, therefore forms the cathode. Then what do you have to write? Number 2, you have to write down the cell representation. How will you write the cell representation? Always the same thing, anode, salt bridge, cathode. Always it is anode, salt bridge, cathode. So what is the anode? Magnesium is oxidized, so Mg is oxidized, so Mg/Mg2 plus. This is oxidation form, and it is standard, means 1 molar. Then double slash, that is a salt bridge. What is a cathode? Silver. Silver is reduced, so what will you write down? Silver in reduced form. So reduced form is first the iron, then the solid metal. So this is your cell representation, isn't it? Anode, salt bridge, cathode, left, right. Then number 3, a cell reaction. In cell reaction, what will happen? You have the anode reaction. What will it be? Magnesium becomes magnesium ion. So Mg becomes Mg2 plus. What has happened? Lost 2 electrons. Then cathode reaction. What has happened? Silver is becoming silver ion. So Ag plus, silver ion is becoming silver, isn't it? So it has gained 1 electron. Now, if you add it, you should get the cell reaction. But I told you, whenever you do this, you always look for the number of electrons. The number of electrons gained and the number of electrons lost always have to be equal. Are they equal? No, they're not equal. So you have to make them equal. What we do? The upper one has 2 electrons and this one has 1 electron. So this is 1 electron. I'll multiply this with 1. This is 2 electron. I'll multiply this with 2. So when we multiply, everything has to be multiplied, isn't it? So upper one, there's no change. Mg loses 2 electrons to form Mg2 plus. But silver, 2 silver will gain 2 electrons. It will form 2 Ag. So these 2 will add, isn't it? Magnesium 2 electrons as it is, and this multiplied with 2. So we'll get this one, isn't it? Now we'll add these 2. What will happen? Mg combines with 2 Ag plus. This will form Mg2 plus 2Ag, isn't it? So this is your cell reaction. Understood? Then the next thing, number 4. What was it? You have to find the cell potential. How to get the cell potential? What we can do? Use the formula E cell. E naught of the cell. How will you find? E naught of the cell is equals to E naught reduction of cathode minus E naught reduction of anode. So one is cathode, other one is anode. What is a cathode and anode? You have already seen. What will it be? E naught cathode. Cathode was silver. So silver in reduction form, and E naught anode also in reduction form, Mg2 plus slash Mg. Silver, how much was the value? 0.80. Magnesium, how much was the value? Minus 2. E naught of silver was 0.80 and E naught of magnesium was given this much. So if I take this 0.80 plus 2.36 volt, isn't it? So this together, how much will it be? When you add it, it will be 3.16 volt, isn't it? So the E naught of the cell or the EMF of the cell is equals to 3.16 volt. Understood? So this type of questions, very easy ones, you can always practice them. Practice this type of sums, whatever I have given you, isn't it? Then we'll see some other things now. Okay, I told you the electrode potentials we get from whatever electrode potentials are there. Where do we get it from? We get it from a series, and that series is called electrochemical series. So this electrochemical series, we'll quickly go through it. Clear? So what is this electrochemical series? We'll see that one. Clear? So let's see. We have electrochemical series. Now this electrochemical series is a series obtained by arranging all the potentials, electrode potentials we are arranging. Clear? So when we arrange, we can arrange the reduction potential as well as oxidation potential. But generally, what we do, we arrange in terms of reduction potential. The topmost one is the highest, and as you go down, it will go on decreasing. So what is this? It's a series. Electrochemical series is a series obtained by arranging all the obtained by arranging all the electrode potentials, standard electrode potentials. Standard electrode potentials, all the standard electrode potentials in the order, or you can say in the descending order of their reduction potentials. So we are arranging them. How will we arrange? In the decreasing order of their reduction potentials. Clear? So when we arrange it, then in that case, what will happen? The topmost will be the highest, and as we go down, what will happen? It will go on decreasing. Clear? The topmost will be the highest, and as we are going down, it will go on decreasing. So if I take this, then generally what will you see? The topmost one will be fluorine. You take fluorine, then it is F2/2F minus is the reduction part, and for this the value is 2.89 volt. Here, this is the maximum. As you go downwards, it will go on decreasing. So what we do, we go downward, it will reach hydrogen. In between somewhere you'll see there is hydrogen, and this hydrogen in reduction form is this one. For this it will be 0 volt. As we go down, we have hydrogen, and then hydrogen will be 0 volt. We can keep on going downwards because hydrogen is just the middle one. As we reach the lowest one, then the lowest one will be lithium. Lithium is Li plus/Li, and this will be minus 3.05 volt. Minus 3.05 volt. So when I take these things, then what you are getting here is highest 2.98, lowest minus 3.05. In between you have 0. As you are going downwards, you can see it is decreasing. So as I go downwards, what I can say, this is the decreasing order of reduction potential. Order of standard reduction potential. Decreasing order of standard reduction potential. Yeah. So this is a decreasing order of standard reduction potential. What you can see here is this is 0. Above this, whatever is there, they all are positive values. And below this, whatever is there, they all are negative values. So positive value, they are easily reduced. Negative value, they are easily oxidized. Yeah. So reduction, oxidation, which will undergo faster, we can compare from that value only. Clear? We have already said higher the value, it is easily oxidized. Understood? So this cell I can show you here. I can just show you on your screen only. You can see just now. You can see here, this is your standard electrode potentials are given. This is a electrochemical series, and this electrochemical series, topmost one, you can see there on the top what you have. On the top you have fluorine, isn't it? Here you can see on top you have fluorine, isn't it? On top you have fluorine. Here you have fluorine. Here in the middle you have hydrogen, and at the bottom you have lithium, isn't it? So from fluorine to hydrogen, all are positive. You can see here all of them, they are positive. Here you can see all of them till here, they all are positive. And then you see the next part on the other side, what will happen? These all are negative. So you can see the upper ones are positive, the lower ones are negative, isn't it? The reactions involving, they are given here only, and you can see here the order in which they oxidize or reduce, that is also given, isn't it? The oxidizing and reducing power is also given there. Okay, so you can see this part. You can see this part, what is given here? Increasing strength of oxidizing agents, isn't it? This one you can see here, this is your increasing order of oxidizing agents. That means if you are going upward, they are becoming oxidizing agents. And if you see here, then what is this? This is increasing strength of reducing agents. So which one is reducing? As you go downwards, the reduction goes on increasing. Understood? So from this we can explain, like we can get the electrode potential, the reduction potential of all the electrodes, isn't it? And we can use these things for calculation of EMF of the cell. We can also use it to compare which of them can easily be oxidized or reduced. The tendency of oxidation and reduction, you can easily see. The ones which are higher, they are easily oxidized, and the ones which are lower, they are, no, it's just the opposite. The ones which are higher, they are easily reduced, and the ones which are lower, they are easily oxidized. Clear? So the negative ones easily oxidized, the positive ones, they are easily reduced. Understood? So this is there. Then apart from this, you can have another thing, that is your you can also compare the chemical reactivity. The ones which are present lower in the series are found to be more reactive than the ones which are present above in the series. So lower ones are more reactive, upper ones are less reactive. That way you can say, from here, suppose I ask you which of these metals will liberate hydrogen from a dilute acid. If I give you dilute acid, which of these will liberate hydrogen. For that, what you can say, the ones which have negative reduction potentials, they all are below hydrogen, more reactive than hydrogen, and therefore they are the ones which can liberate hydrogen. So if I talk about liberating hydrogen, then these all this below hydrogen, they all can liberate hydrogen. But the ones which are above, they cannot liberate hydrogen. Understood? If I say oxidizing agent, reducing agent, we have already seen here, isn't it? So that you'll follow it. Understood? Okay, so these all things, you know it now, isn't it? What advantages and other things we can get from the electrochemical series. You have seen that. Now, using that electrochemical series is always giving you the standard value. Clear? But what happens many times, the electrode which we get may not be standard. Clear? So if it is not standard, then those values will not match there. Okay, whatever values are given in the electrochemical series, they are only for standard ones. For non-standard, we have to do some more calculations, and on that calculations, we can calculate the non-standard ones. Clear? So that we have to do, but before that, what we'll do, one more thing I'll give you. When I give you this electrochemical series, then in that case, you know the elements also, and you also know the electrode potentials also. But suppose I give you something, question where you don't know the elements. I can name the elements as A, B, C, D, anything, isn't it? I can give you the potentials of them, and then you can work out the same thing in a similar way. So let's see whether you can do it or not. One similar question I'll give you, but here I won't give you which metal it is. In the previous questions I've given you which metal was present, isn't it? So I can give you like this way now. Look here. Now I'll give you like this way. Galvanic cell is formed using two standard two standard electrodes, A and B. Two standard electrodes are there. What are they? A and B. A is divalent and B is trivalent. A is divalent and B is trivalent, and their standard reduction potentials are, and the standard reduction potentials are minus minus 3.05 volt and minus 0.13 volt respectively. So I've given you the values. What are the standard values, isn't it? Now from this, if I ask you, write the cell representation, then number one was this, number two, write the cell reaction and number 3, calculate the cell potential. So these 3 things I have given you. Can you do it? Just try. If not, I'll tell you how to do it. Hurry up, try it. Just think. Any problem, you can put there in the chat. I'll see and tell you. Or you can just unmute yourself and then ask.
That
Yes, tell me. Any problem?
sir,
Today?
A is cathode, so A is anode and B is cathode.
Okay, let's see whether you are correct or not. Okay. What we'll do here is we'll see here. Look here. A is divalent and B is
Yes, sir.
trivalent. Means A valency is 2 and B valency is 3. Clear? And the potentials are given this and this. So out of these two, which is higher? Which is bigger? Minus
Sir,
3.05 or the other one? I'll just write down here. Look here. If I say A is divalent to divalent, I can write down A2 plus becomes A. So E naught this is minus 3.05 and E naught B is trivalent. So B3 plus B will become minus 0.13. Now which is higher? B is trivalent and A is divalent. So which is higher now? These two you can easily compare. Which is higher? Compare the two. Negative, whichever value is less is higher. So this has higher reduction potential. Therefore, is easily reduced, isn't it? And forms, what will it form? It is reduced means, so what you are getting here, A is oxidized. A is therefore forms the anode and B is reduced, therefore forms the cathode. Clear? So A is anode, B is cathode. Now the representation, how will you write? Cell representation, how will you write? A is oxidized, so it is the anode. So anode will be, it's always anode salt rich cathode, isn't it? So anode, what is the anode? A is your anode. So A is oxidized. So A slash A2 plus 1 molar, isn't it? And B will be how much? 3 plus 1 molar slash B. So you got the cell representation. Then any problem?
Sir, A, sir, cell repetition is A8/A plus 2. Sir, divalent now.
Divalent. So 2. A is divalent. So A slash A2 plus and B is 3 plus trivalent.
Yes.
Any understood?
Yes, sir.
Next, cell reaction. Cell reaction, what will it be? As usual, we'll write down cathode and anode, isn't it? So anode reaction and cathode reaction. Anode A becomes A2 plus. So A loses 2 electron, becomes, and B3 plus gains 3 electron and forms B. So the number of electrodes, here it is 2, here it is 3, are they same? They're not same. Since they're not same, we have to multiply it by how much? This is 3, so I'll multiply this with 3. This is 2, so I'll multiply this with 2. So what will I get? 3A minus 6 electron gives 3A2 plus, and 2B3 plus 6 electron, isn't it, gives 2B. These two will add, so 3A plus 2B3 plus gives 3A2 plus 2B. This is your cell reaction. You'll add it up. This and this, you are going to add it up. You are getting this 3A, then 2B. Electrons will always cancel. 3A and then again 2B. Clear? So that was your second one, cell reaction. This was number 2, isn't it? Now number 3. What is it? Cell potential. How do you find out? E naught cell, E reduction of cathode. What is a cathode? Cathode is B. So B3 plus slash B minus E reduction of anode. Anode is A2 plus slash A. The values are given only, isn't it? The values, what are the values? We have already seen here. A is how much? Minus 3.05, and B is how much? Minus 0.30. So we are going to put this value here. So what will it be? B is minus 0.13 minus of minus 3.05. Clear? So these two you can easily calculate. Minus 0.13 plus this will be 3.05. So what will happen? You have to subtract it, isn't it? So this will become 2.92, I think, volt. Is it correct or not? Understood?
Yes, sir.
So this is your E naught of the cell. Remember here we had negative values, but cell is positive. This E naught of the cell always comes positive. Remember, it cannot be negative. Understood? So that you'll remember. This type of sums, you'll keep on trying. So today we'll do up till here only. Yeah? We'll end the class here only today. Keep on revising this type of sums.